I can describe the effect of adding a y-intercept to a proportional relationship. Don't let that scare you. Basically, what it's saying is if you have y equals x, which is a diagonal line that goes through the origin, okay, and it's positive, if you add a y-intercept of plus 2, it moves up 2 spaces on the y-axis. If you add a y-intercept that is negative 2, it will move down 2 spaces on the y-axis. Okay, so that's all you need to remember, that if you add a positive y-intercept, it translates the line up. It just goes straight up, however many spaces that had. Okay, and if you add a y-intercept that's negative, that's going to translate it down, however many that number is. It sounds a lot more complicated than it really is. So let's look at this. Tanya graphs the equation y equals 1 over 3x as shown below. That means there's no y-intercept, so it goes through 0, 0, and the slope is up 1 over 3. Now, her teacher then asks her to graph the line y equals 1/3 x, which is the same, minus 4. How will that change the graph? Your choices are: the line will become steeper by 4 units, the line will cross the x-axis at -4, the line will shift down 4 units, and it said the last choice is the line will translate right 4 units. If you add a y-intercept of -4, that line is going to translate or shift down 4 units because all it changes is the y-intercept. It changes it from 0, 0 to 0, -4. And we have another one to look at. This says, Mason graphed the linear equation y equals 4x. So again, no y-intercept. It goes through the origin, 0, 0, and the slope is up 4 over 1. The teacher asked Mason to translate this line 5 units up along the y-axis. What would his equation be for that translated line? If he wants to go 5 up, all he has to do is add a plus 5 to the end of that equation. So your new equation would be y equals 4x, which is what you were given, plus 5.